Welcome. In this video, I'll be talking about electrical load calculations. Remember from my last video, I talked about we have different cables and their sizes. Now we want to know how we can calculate our load and see the effective cable or the right cable we need to use. So for us to be able to calculate any electrical load, we need to understand what an electrical load is all about. So what is an electrical load? This is simply any component of a circuit that consumes power or energy. In a household setting, the most obvious example of electric loads includes lights, bulbs, and appliances. As you're watching this video, just look around you. I can see your TV, your fan, your lights, your bulbs. All these are electrical load. If we note that for power to be consumed, there have to be a presence of voltage and current. Do you remember from our very first video when we talk about Ohm's law that for current to pass through a conductor, you have to have a voltage and current. And the voltage and current needs to happen for power to be consumed. And how then can we now calculate the load that we are using so that we know the right amount of cables that can carry that load, or that we can use to run the installation or the outlet that will carry the load? Let's represent this by saying P, which is power, is equal to current and voltage. So that means the power of our load or our load is equal to the current and voltage flowing through that circuit. So knowing that P, which is the power, which is our load, is equal to I and V. I is the current and V is the voltage. So how then, as electricians, can we determine our load in any circuit or any installation we're working in? Simple, guys. If you notice that every electrical appliances have their own rating in watts, and that is the power they're going to be consuming. Let's take, for example, like your iron, your refrigerator, your television, your heater, your microwave. There is particular amount of power consumption that is dedicated to that electrical device. For example, let's do a quick mathematical representation by saying, imagine your iron is 1200 watts. Then your fridge is 1500 watts. Now, to know the total load that is actually in that house is to add your fridge and your iron together to know the total amount of watts. So let's say 1500 plus 1200 will give you 2700 watts. Now this is a bit dicey and very confusing, because why? As electricians, we want to balance our load on our circuit breakers, and our circuit breakers are actually in amps because they carry current. So what do? Simple. Since watt is power, your voltage is always constant. Although sometimes you have like 210 volts, 220 volts, 190 volts, 230 volts. But the constant voltage that is the acceptable one is 230 volts. So let's say you're having 2700 watts. You don't know your current. Your current is unknown. So and you are using that formula P is equal to IV. I is your current, V is your voltage. Now if you want to make I the subject of the formula, that is your current is going to be what? P divided by the voltage. So simple mathematics, all you need to do is to divide the 2700 watt divided by 230 volts.
So when you do that, that will give you a total of 11.7 amps. So definitely when you have 11.7 amps, you know that you're not going to put that load on any circuit breaker that is below 15 amps on your distribution board. That is very easy. So that is how you calculate your load in any installation you're doing as you work, so that you don't overload a particular circuit on your distribution board.
I want you to try this yourself at home. Determine the load of the following electric equipment: 10 amps, 40 amps, and 60 amps. I want you to determine the load using the equivalent of 230 volts as your voltage. So thank you guys. I hope this video has helped you to know how to convert your load in any installation you're actually going to be working on. So see you in the next video as I'll be discussing tools we'll be needing for installation in this course. If you don't have those tools, after in the next video you will see the tools you need to get so that you prepare yourself for work, because in this course we're actually going to do some practicals and you're going to need those tools. So sit back as I review those tools to you in the very next video.